multiplexing is actually a concept which is used, in some of these, in these switching techniques. So, when we talk about multiplexing, so multiplexing, you can imagine that you have several friends who want to send a parcel or maybe a letter to the same person at the same time. So, instead of sending each letter individually, which is obviously going to be a wastage of time and effort, you need to put, or what you can do is you put all the letters into one big envelope and send that big envelope. And when the big envelope is arriving at the, or arrives at the receiving end, the letters will be taken out and delivered to the person one by one. Similarly, this kind of analogy, if we are going to look into the situation of or in the circumstances of computer networks. So, we have kind of various messages which are to be delivered at the same to the same receiver, and for this kind, if we want to kind of save time and effort, we will be taking one channel and then we will be kind of, we can say, we will be dividing that channel as we did that, putting all the letters in one big envelope. So, putting all the messages or putting all the messages on one particular channel, and that division of channel here is about multiplexing. So, multiplexing, if we are going to define it technically, we can say that it is a method that combines multiple signals or data streams into one signal over the shared medium. So, that shared medium you can take that as that big envelope in which different data streams, which are different individual letters, are being packed onto. So, this process allows efficient usage of resources, and obviously when the resource usage is going to be efficient, it will significantly increase the amount of data that can be sent over a network. So, more data can be sent and received onto that particular network. So, how this multiplexing is going to happen, that we will see. So, it is multiplexing in one sentence. If we talk about, it is the sharing of a medium, or we can call it as the sharing of bandwidth also. So, a process in which multiple signals are coming from multiple sources, or various streams of data are coming from multiple sources, they are combined and then they are transmitted over a single communication line. That communication line could be a physical line, or kind of a physical medium, we can say. So, data coming from various sources is combined and then transmitted over a single communication medium. So, the example which we have just looked into, so the letter coming from various sources are being combined into one big envelope, wrapped into one big envelope, and then that big envelope is kind of sent over the network. So, something of that sort. So, here if we talk about how this is going to happen, we can take the help of a figure which is being shown on the screen. So, you can see here are n inputs, then there is a mux. Mux is actually a multiplexer. Then on the next side there is demux. Demux is a demultiplexer which is going to give n outputs, and in between there is one link, or we can say there are n channels. So, see what is happening on this. There are n inputs which are coming from the senders. Multiplexer, which is a device for multiplexing. So, that multiplexer is going to combine, or kind of we can say collect all these n inputs and bundle them over together, and these are going to be kind of sent to over this one link, which is again divided into n different channels in order to avoid we can say overriding one or the more messages. So, at the right side if we look into, so there is a kind of demultiplexer. So, demultiplexer is again a device which is there to kind of separate all those n inputs into various into corresponding n outputs. So, multiplexing, and then at the receiving end it is kind of we can say converting into demultiplexing. So, multiplexing is combining of n inputs into one, and demultiplexing is taking one input and giving the kind of separate and outputs from it, and all these n inputs in the form of one bundle, or we can say in the form of n channels, are sent over one particular link. So, what is happening in this is, this link is kind of we can say efficiently utilized, or we can say this is better way of utilization, or kind of efficient utilization of the link. So, this is what is we can say is the process of multiplexing. Now, moving forward, if we talk about usage of multiplexing, or kind of we can say the advantages of multiplexing, it is used in variety of purposes in data communication. Obviously, the capacity of the networks is being enhanced, because on that one particular link, all the n channels can be kind of used at a simultaneous it's used simultaneously. So, obviously, this is going to enhance the efficiency of your what we can say efficiency of the network or efficiency of the channel. Now, looking into the usages of multiplexing, or I can say advantages of multiplexing. So, one is the efficient utilization of resources, because it allows multiple signals to share the same communication link, making most of the available bandwidth. So, whatever bandwidth is available on that particular link, most of them, most of it can be used. So, especially this is important in all those environments where bandwidth, available bandwidth is limited. Moving on to the next usage or the next application area is the telecommunication. So, in naive telephone networks, multiplexing enables the simultaneous transmission of multiple telephone calls over a single line, enhancing the capacity of the network. So, this is a very common scenario in telephone network, in which multiple telephone calls are being kind of transmitted or being communicated over a single link or over a single line. Apart from telephone network, or apart from telecommunications, if we talk about the internet and data networks, so multiplexing is also used over there in internet and data networks, in order to transmit the data from multiple users over a single network line, improving the efficiency and speed of data transfer also. So, not only the terrestrial networks like your telephone networks or internet and data networks, satellite communication is also one of the usages of multiplexing. So, multiplexing help in efficiently utilizing the available bandwidth on satellite transponders, which and that allows multiple signals to be transmitted and received simultaneously. So, whether it is a kind of internet or data network, or it is a telecommunication network, or it is a kind of a satellite communication scenario, in all the networks, or in all type of networks, multiplexing is used kind of heavily, because this is going to give us efficient utilization of resources. Now, moving forward, looking into, if we look into the types of multiplexing. So, we have three types of multiplexing. One is frequency division multiplexing, which is known as FDM. Then we have TDM, which stands for time division multiplexing, and then we have wavelength division multiplexing, which is WDM. While your time division multiplexing is again divided into kind of two types. One is synchronous time division multiplexing, which is synchronous TDM, and another one is statistical time division multiplexing, which is statistical TDM. So, now we will be looking into all these three types into detail, and see how this multiplexing is going to happen when we talk about these types of frequency division multiplexing, time division, and wavelength division multiplexing. Frequency division multiplexing, if we talk about, it is a type of multiplexing where the bandwidth of a single physical medium is divided into number of smaller independent frequency channels. So, for example, let us say we have kind of a radio network, and in radio network we at 104.0 FM we have a different kind of different we can say communication going on. At 107.2 we have a different, and at 91.1 or 2 we have kind of different. So, this is what we called as frequency division multiplexing, where the bandwidth, there is a single physical medium and that bandwidth is divided into different frequency channels, which are obviously kind of smaller than that whole bandwidth, because we are creating the fragments of that bandwidth, and obviously they are independent. They being independent is very important, because what is happening here is actually kind of they should not overlap, or I mean the data of the channel, different channels should not overlap with one another. So, in order to understand the concept of frequency division multiplexing, let us take a look at kind of a figure which is available on the screen. So, we have some input lines, then we have a multiplexer, and I have already told you that multiplexer is something which is kind of taking the n input lines and giving one combined kind of we can say bunch of that data. Now, there is one particular link, or we can say one particular medium. That medium is divided into different channels, which are 3 channels over here, which is channel 1, channel 2 and channel 3. So, all these 3 channels are carrying the input, and at the receiving end, which is in equipped with another device, which is demultiplexer. That demultiplexer is going to take all these all this data which is coming on one particular physical medium or one particular we can say link, and then it is kind of giving different output lines. So, what is the kind of we can say the example here, the radio network is kind of a best example of this frequency division multiplexing, where each and every channel is operating on a different frequency. One channel is operating on 91.1, another one is operating on maybe 100.1, and so on and so forth. So, you have you must have listened and seen all these radio channels. So, that is actually an example of frequency division multiplexing, in which one link is one communication link is being divided into different channels. So, frequency division, as I have already told you, is used in radio as well as also in kind of television transmission. In FDM, we can have a lot of interchannel crosstalk, because in this type of multiplexing, bandwidth is divided into frequency channels. Now, the idea is to have kind of we can say a clean talk, in which there is no interchannel crosstalk. But if it occurs, what should be done? So, in order to prevent that interchannel crosstalk, unused strip of bandwidths must be placed between each channel. So, what does it mean? So, this means, say for example, one particular channel is operating at let us say 90.5, then you must have this 91.5 as an unused strip of bandwidth, and then maybe 92.5 is again kind of busy, or again being used for a unique communication. So, some unused strip of bandwidth must be placed between each channel. So, these unused strips which are placed between each channel, these are kind of known as guard bands. So, in order to understand the concept of guard bands, let us see the figure. So, we have channel 1, then we have channel 2, and then there are different channels, channel 3 and so on and so forth. Now, please notice that channel 1 and channel 2 are although they are adjacent to each other, but they are not kind of we can say just next to each other. There is a unused strip of bandwidth between them, so there is an unused strip of bandwidth between channel 2 and the next channel 3, and so on and so forth. So, all these kind of all these unused strip of bandwidth, or all this unused bandwidth are basically known as guard bands, which are there placed deliberately in order to avoid this inter-channel crosstalk, if we talk about. So, yes, guard bands, or the concept of guard bands in case of a frequency division multiplexing is kind of, we can say, very, very important. So, this was frequency division multiplexing. Now, moving on to time division multiplexing. So, time division multiplexing, let me give you an example of time division multiplexing here. So, let us say you are listening to one particular channel, maybe any example you can take. Let us take random example of 92.7. So, in 92.7, within that particular channel, you are sometimes sometimes some songs are being played, then there is kind of a portion of advertisement, then there is a portion in which kind of radio jockey is having some conversation with his or her listeners. So, basically in between the songs, then maybe that conversation, then maybe then advertisement, that channel is actually being divided, or the time of that channel is being divided, so that kind of, let us say, for 2 minutes or maybe for 5 minutes we are going to play a song, then there will be an advertisement of 2 minutes, then there is a conversation of 1 minute, and then there is again a song. So, what is this? This is actually division of we can say time. So, this is what the time division multiplexing is. In time division multiplexing, instead of sharing a portion of the bandwidth in the form of channels, which we did in frequency division multiplexing, the time of a particular channel is shared, as I have given you the example, and each connection occupies a portion of time in the link. And in this time division multiplexing, which is TDM, all signals operate with the same frequency at different times. So, that is why I have told you that a particular frequency 92.7, some songs are being placed, and some songs are being played, then there is a conversation with the radio jockey, and then so on and so forth. So, this is actually a beautiful example in order to understand the time division multiplexing. So, here you can see the figure of time division multiplexing. Now, please recall the figure of frequency division multiplexing, in which it was like there was one link and it was shared between different channels. Now, here there is a link, but instead of having different channels operating at different we can say different frequencies, the time is divided. So, for example, once there is kind of there is we can say communication which is demarked as 1, then there is a communication which is demarked at 2, and then 3 and 4, and then there is time, or we can say the turn of the communication which is earmarked as 1, and so on and so forth. So, these are actually kind of, we can say, this is a example of time division multiplexing, in which the time onto a particular link is being divided into different transmissions rather than the bandwidth. So, bandwidth was actually divided into the frequency division multiplexing, while in case of time division multiplexing, it is the time of that channel or time of that link which is being divided into different incoming inputs. Now, time division multiplexing is actually of two types. One is synchronous time division multiplexing, and another one is asynchronous time division multiplexing, which is also known as statistical division multiplexing. So, these are the two types which are actually kind of we can say here, in case of undergraduate studies, we just need to know about the names of this time division and time division, types of time division multiplexing, which are synchronous and asynchronous. Moving further, the last type within the multiplexing is wavelength division multiplexing. Now, in frequency division multiplexing, we divided the frequencies in case of time division multiplexing, we divided the time slots. Wavelength division multiplexing, when we talk about, it is a multiplexing technology which is actually used to increase the capacity of optical fiber by transmitting multiple optical signals simultaneously over a single optical fiber, each with a different wavelength. Now recall the concept of optical fiber, in which the data is being transmitted and by getting reflected by the inner glass cores, that data is kind of going to be received at the receiver's end. So here different signals are being we can say transmitted or thrown. Each signal is carrying a different wavelength of light, and the resulting signals are combined into single optical fiber for transmission. So there are various signals. Each signal is carried on a different wavelength of light. Resulting signals are combined into a single optical fiber for transmission. At the receiving end, the signals are again separated by their wavelength with the help of demultiplexer, and then routed to respective destinations. Now, which is the kind of, we can say, application of this kind of wavelength division multiplexing. So, this wavelength division multiplexing is used in telecommunications, cable TV, internet service providers, data centers for high speed, long distance data transmission, and so on and so forth. Now, if you want to have a look at the figure of which is describing this wavelength division multiplexing, which is WDM. So, here we have various links, and different transponders are attached to separate links. Then there is a multiplexer. That multiplexer is going to take all the data or all the signals which are onto the different having the different wavelength, multiplexed them together, given onto a single given in on a single optical fiber. At the receiving end there is a demultiplexer, and that demultiplexer is going to do the opposite scenario or the opposite task of this multiplexer. Now, if we talk about the advantages and disadvantages of multiplexing, so obviously bandwidth is going to be used efficiently, because multiple signals are going over a single channel. Data transmission obviously is going to get a boost, the amount of data that can be sent over a network. Obviously it will enhance the transmission capacity. Multiplexing allows the networks to easily expand and accommodate more data streams without requiring significant changes to the existing infrastructure. And obviously a flexibility is also introduced, because various types of multiplexing like TDM, FDM and WDM can be used on the basis of specific needs of the network. So, flexibility, scalability, efficient use of bandwidth and increased data transmission are the advantages. On the other side, if we look into disadvantages, there are synchronization issues. Yes, so ensuring the multiple data streams remain properly synchronized is one of the challenge. Then combining multiple signals will introduce delays, and then each data stream needs to be processed and synchronized, and the opposite is to be done, which is the demultiplexing at the receiving end. So, latency obviously is one of the disadvantages. Then signals over long distances can be can experience degradation and interference. That may require signal boosters or repeaters to maintain the quality, and also it is kind of in order to avoid congestion and ensure efficient operations, proper resource management is required in terms of allocating and allocating resources for multiplexing. So, in this lecture we looked into the concept of multiplexing and its different types, which are frequency division multiplexing, time division multiplexing, wavelength division multiplexing, and towards the end we also looked into some of the advantages and disadvantages of multiplexing. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.